Alright, today's date, 6/7/18. It's my brother's birthday today.
How old is your brother?
I do, I got a brother, Charlie. Yeah, he's the bigger version of me. Seriously, he's the bigger version. He actually played college football. Yeah.
How old is he?
He's 2 years younger than me, so he'd be 57 today. No, 56. Yeah.
So you're 58.
8. Yeah.
Oh yeah, you told me you were 7 years away from him.
Yeah. Okay, draw a graph. So Landon hops on his bicycle and travels 10 miles per hour for 10 minutes, okay? Then waits at the bus stop for 20 minutes. He jumps on the bus and travels for 40 minutes at an average speed of 50 miles per hour. He arrives in Wenatchee and walks 5 minutes at a rate of 4 miles per hour. Okay, so this should be pretty easy. I don't think anybody's going to have a real hard time with this. So he's going to hop, he's going to be basically at home, and he hops on his bicycle and he's going to go 10 miles per hour, right, for 10 minutes. So it's going to be something like that, okay? Right? Then he waits at the bus stop. So when he waits at the bus stop, he's not moving, is he? So he's going to be at the bus stop for 20 minutes. So he's going to be just sitting there. So he's going to be down here because the rate is 0, right? He's just chilling at the bus stop, right? Then he jumps on the bus, travels for 40 minutes at an average rate of 50 miles an hour. Okay, so 50 is up here. And he's going to have 40 minutes of that. So he's got 10, 20, 30, 40. God bless you. Add about 50. So it's like right about there, average rate. So this goes up like that because the bus is going to zoom up, right? And then he arrives in Wenatchee and walks 5 minutes, rate of 4 miles. So then he's all the way down here at 4 miles per hour, right? For 5 minutes. So the graph looks something like that. How's that? How's that? Here he's waiting at the bus stop, so the rate's 0, right? That's a loud bird.
Go away.
Sitting on my rack. Yeah.
Oh, yeah.
No, Jacob's going to get him. There you go. Okay. All right, number 2. So it's a piecewise graph. So I see 1, 2, 3 equations, right? So first of all, equation 1. Equation 1 is down 1 over 2, down 1 over 2. Okay, so it's going to be a y equals a down 1 over 2x plus. It got erased, but it would have gone through negative 1/2. It got erased, but this graph would have gone through at negative 1/2, right? But it got erased, so minus 1/2. Okay, if you kept it going, it would have crossed here, but it got erased, okay? Equation 2 then looks like an upside down parabola, doesn't it? 1, 1, 1, 1, 2, 4. So it's going to be a y equals a 1 minus x squared, okay? Upside down parabola starts at 1, right? Then equation 3 looks like it's y equals, looks like it's up 1 over 1, up 1 over 1, up 1 over 1, but it really went through, so it's y equals a 1 over 1x. And then right here at 1, 2, 3, 4, 5, it would have gone through at 5, at negative 5, but it got erased, right? So it's a piecewise graph, so I'm going to go first of all, f of x equals, and all 3 of my pieces, negative 1/2 x minus 1/2. Stephanie, do you want to go outside or do you want to be quiet and pay attention so Tamlin can learn, please?
I was reading to her something.
I know, but she wants to listen to this. 1 minus x squared, x minus 5. Now, the thing is we have these pieces and they're connected there, 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 and there. Okay, so I have to put those constraints in, right? So the first graph exists between 1, 2, 3, 4, 5, negative 5 to negative 1. So negative 5 is less than or equal to x, less than or equal to negative 1. Okay, that's the region that graph 1's in. Graph 2 exists between negative 1 and 2. Negative 1 is less than or equal to x, which is less than or equal to 2. Oops, I got to be careful on my equal signs, don't I, Katie? There we go. So I have equal there, but not equal there, okay? Then graph 3 exists between 2 and 5. 2 is less than x, which is less than or equal to 5. And I had to be careful on my equal sign because I can't count negative 1 twice, and I can't count 2 twice. So I put the equal sign here and not there. And it doesn't matter which one gets the equal sign as long as they both don't get it. Okay? How am I doing? Okay.
Wait, why is there a minus 1/2 after minus 1/2 x?
Great question. So this graph would have started right here. right? Does that make sense? But we erased it. I mean, when normally we do a line, we've got to go to the y-intercept, we start, then we do the up one over, right? So it would have started right here, AB at negative 1/2. But we erased it because it's not in that region. Good question. Okay, now let's translate this graph. We're going to translate it 3 units to the left and 2 units up. So I'm going to go ahead and take and get a different color. Let's see if I can find a colored pencil. I had one. Where's my colored pencil go? I'll use a red pen. Okay? So let me translate it. So I'm going to go 3 units to the left and 2 units up. So let me take this point right here. Let's go 1, 2, 3, and then 1, 2. Okay, that's that point there. So this point, then we can go 1, 2, 3, 1, 2. Okay. My parabola, we can take this point and go 1, 2, 3, 1, 2. Right. And then we can take this point 1, 2, 3, 1, 2. Starting to get it like that, right? And then this one we could take this point over 1, 2, 3, 1, 2, and then maybe this last point 1, 2, 3, 1, 2. Okay, so here it is. Translate it. So I took the whole graph up, 2, and to the left, 3. Okay, now what happens is my constraints also had to move, right? My border lines had to move to here, okay, to here, to here, and to here. So I moved my graph and I had to move my border points. Okay, how am I doing? I'll slow down for a second, let you get caught up. So I moved my entire graph over 3 up 2. So here's my graph in red, moved over 3 up 2. So here's my new graph, it's been moved, right? But when I moved it, I also had to move the border points. So that they're no longer connected here, or stops here. It's here. They're no longer connected here, they're connected here. They're no longer connected here, they're connected here. Okay, and there's the end. Okay, so I get my border points, right? Now, what's the new equation? Well, the new equation is going to be, ready? F of x equals. Okay. So, one way to do this is we take, and if we're going to move it to the left 3 units, we're going to add 3 inside the x. We're going to add 3 inside the x. We're going to have a negative 1/2 times an x plus 3 minus 1/2, but we also went up 2 units. We're going to go plus 2. And I'll stop for a second. I'll explain what I did, okay? And I can even do the dance. Remember the dance? If you move it left to right, we're doing it inside the parentheses, right? I'm going the opposite direction, so if I have to move it to the left, I make it plus 3. So it's the opposite, okay? So here's my horizontal movement, and here's my vertical movement. Now I can simplify this, and I will simplify that later, okay? Second graph, I'm going to have a 1 minus an x plus 3 squared plus 2. Here's my horizontal movement. There's my vertical movement, okay? Graph 3 is going to be a parentheses and x plus 3 minus 5 plus 2. Here's my horizontal movement, and there's my vertical movement, okay? Now, I'm going to simplify these briefly. I'm going to use another piece of paper to do this because I'm going to need a little bit of room to do these, okay? So the first equation would give me a negative 1/2 x minus 3/2 minus 1/2 plus 2, which would give me a negative 1/2 x. Let's see, that'd be a negative 2 plus 0, right? Okay. And then this one would simplify to a 3 minus an x plus 3 squared. And this graph would turn out to be, let's see, 3, 2 makes 5. That'd be 0 also. That'd just be an x. Now, because their borders moved, then the constraints, this negative 5 to negative 1, is going to go back by 3, right? Katie?
Would it be minus 3?
Yeah, for this one, yes. Yes, and that minus 3 with this positive 3 made us no 3's.
Oh, okay.
Good question. Okay. I would like it to. If you
Like,
don't,
are
I
you
won't
gonna
count
mark
wrong.
us down?
No, I will not mark you down if you don't. How's that for a deal? Okay. I'm going to, though, because, you know, I'm the math guy, right? Thanks, Quinn. Good job. I'll see you Thursday. I'll see you tonight. Okay. All right.
2:30 or
3.
3?
Okay, so then I also had to move the constraints. So the easiest way to move the constraints is just I moved it back, right? So instead of -5, this is going to be a -8. Does that make sense? Moved it back 3. So I'm going to go from -3 less, -8, sorry, -8 less than or equal to x, which is less than or equal to -4. So I move the constraints back 3 as well, right? This gets moved back 3, so this is going to be a -4 less than x, which is less than or equal to, move it back 3, -1. This got moved back 3, so it goes from 2 to 5. So I'm going to go 2 back 3, I'll go -1 is less than x, which is less than or equal to, move this back 3 to 2. Okay? Does that make sense? Hopefully it makes a little bit of sense. I just shifted everything back 3, so I just changed all of my borders, just shifted all the way back 3, okay? There, there's my new equations for my new graph, okay?
Is the test tomorrow like fairly short?
Yeah, it won't be long. Okay, are you ready for, nope, I'll wait for you. I'll wait for you. I will. You are very, I don't mind waiting for you.
Thanks.
Mr. Davis, can I just do something?
May as well, right? Long waiting.
All that, that's all I ever wanted.
I download Messenger, so it's fun.
Yeah, I tried to find my Apple ID for
Can I look at Miss Kelly's sign?
Casey's iPad so I could message people.
Okay, how am I doing? Am I ready? Ashley, am I ready? Okay, so let's do number 5. Okay. Okay. So 5. Let's put 14 into G. So G of 14 is equal to the square root of 14 plus 2, which is the square root of 16, which is 4, right? So G of 14 is just equal to 4, right? And then let's take 4. Okay, you ready? Put 14 right there. You with me? Tammy, am I doing okay? I took 14. These are the days you miss because of the baby. Taking the 14, I'm going to put it into G. So the 14 goes right there into G. So what's 14 plus 2? 16. Square root of 16 is 4. Want me to do it again? So take 14, I plugged it right there into G. 14 plus 2 is 16. Square root of 16 is 4. Okay. Now we take that answer, which is 4, and plug it into F. So we're going to go F of 4, which is 2 times 4 squared plus 3. 16 times 2 is 32, 33, 34, 35, right? Should be 35 as my answer, okay? So Tammy, I took my 4, my answer, and plugged it into the F function for x, right? 2 times 4 squared plus 3.
So f of 4 is also equivalent to f of g, right?
F of 4 is the equivalent of F, no. F of 4 is not equivalent to F of G. I don't get your question. Ask it again.
Because 4 is the g value, right?
4 is the G of 14 value.
G of 14.
That's,
All right.
then I'll say yes. Okay, good. Okay, now.
Wait a second.
Okay, you want to do it again?
No, just the 4 squared is 16.
Times 2 is 32.
Ah, okay. Yeah,
Okay.
I got it. I was doing that.
Okay, yep. Okay, put the 2 into F. So this we're going to do the other way. We'll put the 2 into F first. We'll go F of 2. So you always work your way on the inside out. F of 2 is equal to 2 times 2 squared plus 3, right? That's going to be 4 times 2 is 8, 11. So F of 2 is 11, right? Yeah, so you get 4 times 2 is 8 plus 3 is 11. Got it? Okay. Then we're going to take 11. We're going to plug 11 in here, okay? Or 11 into G, yeah. So we're going to go G of 11, which is going to be just simply the square root of 11 plus 2. Square root of 13, which, good enough.
5.
Yeah.
You guessed 3.5.
Yeah, I'm going to leave it square root of 13, but yeah. Yeah, square root of 13. Okay.
Or you can use the fancy commands.
There you go. Now, 7. Guys see it? 7's got an x. So my answer is going to have an x answer, okay? There's no numbers. It's going to have an x answer. So I'm going to take g of x, which is this, and I'm going to put it into f. So I'm going to put it right into there. So I'm going to go 2. So I'm going to take the square root of x plus 2 and plug it right there. Okay, so I'm going to take this value, plug it right in there. Okay, and so then I have a square root of x plus 2. Square cancels the square root, so I'm left with a 2 times an x plus 2 plus 3, right? I get a 2x plus 4 plus 3, or a 2x plus 7. So I get an x value. I do get an x answer because I didn't plug in any numbers. I plugged in an x, right? Okay, thumbs up. Okay, ready? Turn page. Okay. Okay. Okay, 8. So I'm going to use, so to graph number 8, start at 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 is way up here. Shoot. I'm going to have to borrow my pencil. I'll share it with you for just a second. Okay, I need it. But I'll share it with you, okay? Because I need to erase. Okay, and I'll give it to you. So 1, 1, 2, 1, 2, 3, 4, 5, 4, 5, 6, 7, 8, 9. Okay, here it is right here. Oops, I'm off by 1 right there. I'm off by 1. That's why I need my eraser. That's why I need my pencil. See? I could have used whiteout though, right? Okay, there it is. And then here you go. So now, it does not have an inverse. It doesn't. Because it doesn't pass that horizontal test. So it has no inverse. Saddy face, no inverse. But since it does not pass the horizontal test, we're going to fix it. We're going to say, well, wait a minute. What if I only have this part of the graph only, right? And I erased this back half. Well, in math, you just can't erase because this is not an art class. You can't erase. You have to say, well, the reason I'm erasing is because now I'm going to say x has to be greater than or equal to 0 only. Okay? So I have the front half of the graph, and now it has an inverse. So now smiley face has an inverse, right? So if we want the inverse equation, which I'm going to ask, I have this y equals 9 minus x squared, but the inverse equation, to find the inverse, you just switch the x and y, right? So we've got x equals 9 minus y squared, and let's solve for y. So to do it inverse, I switched x and y's, right? That's what makes this inverse. And then I'm going to solve for y. So I will, let's bring over the y squared. That's easier. Bring the y squared this way, and I'll bring the x that way. So y squared is equal to 9 minus x. You okay with that? Just a little switcheroo. Brought over the y squared, brought over the x. I'm going to take the square root. Normally it's plus or minus, but because I got rid of the negative half, it's not plus or minus. It's just y equals the square root of 9 minus x. Okay? Now, if we want to graph that, and I'll give you a second to catch up, and that is the inverse. We'll write as f inverse of x. Okay, if you want to graph that, the easiest way to graph it is just go and reverse the points. For instance, this is the point 3, 0. This is the point 3, 0. Its inverse would be 0, 3. Okay. This is the point at 2, 5. Its opposite would be at 5, 2. 1, 2, 3, 4, 5, 2. This is the point at 0, 9. Its inverse would be at 9, 0, and its inverse graph would look like that. Okay, there's the inverse graph.
Oh wait, what? I didn't hear that. What? Oh, you're wrong. That's the
Yes.
So your point is 3, 0.
Becomes 0, 3.
0, 3. That's right. I got that.
I got 2, 5 becomes 5, 2.
5. Oh, I was just going the wrong way for some strange reason.
It's okay. It's all good. Okay.
I don't know.
Okay. Now we're almost done, right? So the chart shows water use in Leavenworth in relationship to temperature. Okay. So make a scatter plot of the data. So let's just make a scatter plot. 55 degrees, about 71.3 gallons, maybe about there. 6 degrees, about 78, maybe about there. 65 is about 87, maybe. It looks linear, doesn't it? Makes sense. 70 degrees, it could be a 96 gallons, maybe right about there. 75 and about 106 gallons, maybe right about there. And 80 degrees, we use 117 gallons. 117 is maybe. Sure looks linear, doesn't it? Does look linear to me. So I'm going to use my calculator in the stat plot. Remember we had how we did that? Okay, so I'm going to go to list 1. I'll let that be L1, L2, right? So we'll go to we'll go to stat, edit, clear, and clear. List 1, 55, 60, 65, 70, 75, 80, right? And 71.3, 78.7, 86.9, 96, 106, 117. Okay? Got them all in, right? I think it's linear, so I'm going to go to my stat, calculate. I think it's a linear regression. Sure looks straight to me, doesn't it? Right? Enter L1, comma, L2. And I get an answer. Yeah, I get an R of 99 point. Yeah, I got a good R. So linear, I'm going to say y is equal to my 1.826x minus about a 30.6. Okay. Got my equation. And I can even change it to gallons. I can say, okay, gallons is equal to 1.826 T, thank you, Katie, T for temperature minus 30.6, okay? Now, again, you've got to remember that the graph itself is only relative to this, because if the temperature is 0 outside, there's no such thing as negative gallons, right? Yeah, it could be. Maybe your pipes burst. But then nobody's going to be putting water into your house. Well, no, if your pipes burst, right? Maybe. Anyway. Okay, so let's put 85 into my equation, right? So I got a temperature of 85, so I'll go, okay, how many gallons is equal to 1.826 times 85 minus 30.6. Try that out. Click, click, clear. 1.826 times 85 minus my 30.6, and I get an answer of about 124.6 gallons. Okay. So, and then lastly, use your model to predict the temperature when 50 million gallons are used. So I'll just set it equal to 50 and solve, right? I'll wait for you. So then this is gallons, so I'll put the 50 here, right? So I'll go 50 equals, right, and this, yep, right. Good, very good question, Katie. Good observation, thank you. 50 is equal to a 1.826x minus a 30.6, right? We'll just solve, right? Plus 30.6, 80.6. Divide, right? Let's see, 80.6 divided by 1.826 About 44. So the temperature would be about 44 degrees. How's that?
Perfect.
All right. That's all I have. So tomorrow should be pretty easy, right?
Yeah.
Yeah.